So, first one is this writing task. I'm not going to write the whole thing out, but what I want to just pass along with that is the idea of kind of describing your steps and having reasons. So as you kind of check your answers with this, I hope that you can listen to what I'm saying and get a feel for it. It's kind of reminiscent of what we did with proofs, and it's just in general a good practice of describing what your work is. So in this particular problem, we're told that angle BAC is 40 degrees, so I'm going to mark that right there. And we are asked to find BDC. So this is the angle we want to find right there. And so my hope is the thought process that you had is you came to this problem and you said, because angle BAC is inscribed, then it must be half its intercepted arc, which means that the measure of B arc BC must be twice of 40 or 80 degrees. Again, half an inscribed angle, an inscribed angle is half its intercepted arc. Well, now we come down to angle BDC, and because angle BDC is a central angle, it equals its intercepted arc, and so we would be able to just confirm that it is 80 degrees, and we are done. So it doesn't need to be excessive. Obviously, I would write out a little bit more than that, but hopefully you see the kind of flow. Inscribed angle means that it's half its intercepted arc, so the intercepted arc is 80. If we then look at the central angle, it's equal to the intercepted arc, so it is still 80 degrees. Going on to number 2, we are told that TP is 70 degrees, and that is for the arc, so I'm going to measure that right there. And then we are asked to find our S, which we don't know, which I could just call X. There's two main ways to look at this one, but they basically use two ideas. One idea says that all arcs of a circle must add up to how many degrees, and hopefully you just said 360 degrees. And we also can take advantage of the detail that congruent chords, those are these straight segments, ST, SR, RQ, QP, have congruent arcs. So we could look at this problem and say, hey, if RS is X, then that means all of these must also be X, meaning our whole circle must be 4X plus 70 equals 360. Take away the 70. 4X is equal to 290. Dividing by 4, and X must be equal to, what is that, 72.5 degrees? 4 times 70 is 280, 10, 2.5. So X is 72.5 degrees. You could also approach this problem not with setting up one single equation, just kind of piecing it together. You could say, hey, I know 70 degrees is accounted for, which means what's left is the 360 minus 70. That gives me 290. And then I know that the 4 parts must all be equal. Divide that by 4. And of course, hopefully you see that the algebra is the same, and you would still get 72.5 degrees. So whether you wrote a single equation or you kind of pieced it through, they both work. Moving right along, if you can hear the meowing, the cat has decided to come say hello. So we'll see how she's doing. She's been very needy lately, but she's pretty happy as well. So, moving right along to part 3, we are told that FEFG is 120 degrees. We are also told that FE is 7 meters, and we are asked to find the length. Notice that it says length. This means we want to know the actual measurable distance from G to E. And so our blueprint for that was this. The measurable distance of the entire circle is circumference. But then the whole point is we don't want to know the whole circumference. We only want to know a part of it. Specifically, we want to know this part right here, the 120 degrees, which is a portion of the whole thing. So if we put that together, we want to know the part of the circle. I know. Oh, you saying hi? Yep. Not on the desk. I'm sorry. Part of the circle. Okay. So the part of the circle is going to be the 120 degrees over the 360 for a whole circle. Circumference we should recognize as being 2 pi r. So when we use that as our formula, we've got 2 pi times our radius of 7. So when we multiply those two together, you've got 120 over 360 is 1/3. 2 times 7 is a 14 pi. And sure enough, we can just leave our answer as 14 pi over 3. Technically throw meters on there, because the whole point is we are dealing with arc length. Moving on to part 4. We're given some details here. IL is an 8, LH is a 9, and then JK is what we want to know. This is a hidden problem. It is not explicitly mentioned, but if we take a look at it, we always have the option to draw in an extra radius, and if we do, you might recognize this problem as being a 4 problem. Now, as we take a look at this, we can also take note, this line, the radius that we've drawn in red, is the radius. And last time I checked, I to h is also a radius, which means we know this side is 17. So now we've got a right triangle right here with 17, 8, and an unknown for JL. If we put those together in order to set up Pythagorean theorem, I believe this comes out nicely. We're going to find out. That's 64. That's 289, I believe. Let's find out. I think 17 squared is 289. Nope. 17 squared. Oh, come on. Calculator. Go. 17 times 17. That's 14. Failing. So hard. Okay, 289. Sure enough, we gotta subtract our 64, which is gonna put us at 225. I was thinking this was a triple, but I wasn't sure. So that's 289. Subtract your 64 from both sides. You get that JL squared is 225. So if you take the square root, we get that JL is 15. But be careful, because they ask us for J to K. So to get that entire chord, we just have to double it. And so we get that JK is equal to 30. One detail you might not remember is that if you draw on a radius such that it meets a chord at a right angle, it must bisect that chord. So that is one of the things that we can take advantage of. And we do get a final answer of JK is equal to 30. And then there's one to go, and this one always has a little bit of fun, because it uses a detail that we've almost always all forgotten, especially this time, seeing as how this distance learning thing leaves a little to be desired. Anyways, ZWX. So ZWX tells us that this right here is 3x plus 15. WXY tells us that this is 8x plus 20. And then y, what is that? Y, no, did I do this wrong? WXY, and then we've got XYZ, I just can't read for some reason, is 10x minus 30. Okay? And we want to find x. And the challenge is, it seems like we don't have enough. Because at face value, it seems like we would need all 4 angles. We know all 4 angles in a quadrilateral add up to 360. Clearly this isn't None of these are 90 degrees, so we can't use that. We don't know about anything in terms of the sides don't look parallel. So anything like alternate interior, congruent, or anything like that just doesn't make sense. So what do we need to do? The key here is going to be inscribed angles. And this would have been mentioned somewhere along the lines, but it obviously would have been a stress because we didn't have whole lessons. But here's what I want you to think about for a second. I want you to pick any 2 points on a circle. Okay? And what I want you to do is I want you to draw an angle on one side. And you can draw a totally different angle on the other side. Okay? And what our focus is going to be is we've got one inscribed angle right here, and we've got another inscribed angle right here that are clearly not the same size. And so here's what I want you to think about. This inscribed angle up here with a single tick mark has this as its intercepted arc. And we know that an inscribed angle is half the intercepted arc. This angle down here with 2 tick marks has this for its intercepted arc. And again, we know the same detail that an inscribed angle is half the intercepted arc. Altogether, these 2 arcs in red make up the whole circle. So we know that the whole circle must be 360 degrees, which means these 2 angles, which are opposite each other but share the same endpoints, must be half of that, or 180. And so what that means is any inscribed quadrilateral, opposite angles must add to 180. So what I'm going to do for this problem is I'm going to take my opposite angles. I'm going to take the 3x plus 15 for angle W, and I'm going to take the 10x minus 30 for angle Y. I'm going to subtract them, and guess what? They must be equal to 180 degrees. So if I take those values and I put them together, 3x and 10x make 13x. 15 minus 30 is a minus 15. Set it equal to 180. This pen's about to die. Hang on! I'm going to add 15 to both sides. 13x is equal to 195. Divide by 13. And snap. It's got to end in a 5. Was that like 15? No, can't be 15. 195 divide 13, assuming I did this right. It is 15. Wow, my mind really can't think right now. Failing so hard. I now know x is 15. In this particular case, fortunately enough, if we go back to our directions, well bam, we just need to find x, not any particular angle. So we can circle that, move about our day.